Hi, good morning, evening, and afternoon. Namaskar. My name is Supal Yadav, and I completed my MSc in Physics, specialized in electronics from University of Allahabad. I uploaded my demo video from here. Actually, I have not prepared, so I make it video on my mobile. So I will start. When we take a class, we will derive the equations. We make a write up for equation definitions, examples, and draw the diagrams and derivation also. But here I try to overview about what of physics and which of the branches is the most significantly connected really about it. So let's start. So for understanding the broad about the physics, I chose the topic is wave and oscillations. So what is a wave? Simple question, why I choose a wave? Because it's connected the more of the subjects. So I try to give you a broad analysis about the physics. So let's start about a physics, about a wave. So what is the wave? Waves is a disturbance in medium. Disturbance in medium. If you can disturb any medium, that means you create a wave. But question arises, which type of mediums you can which type of mediums? The mediums which have elasticity and inertia, if you disturb such type of medium which have elasticity and inertia, you can generate a wave. Okay, we can generate a wave. Okay, we have generated a wave. But what's the wave of motion? The wave motion means a transfer of energy. You know what the transfer of energy? You have previously studied about the thermodynamics. So remember that. Don't be confused. Transfer of energy will be studied in a wave and oscillation. But when you study the transfer of energy as well as a transfer of matter, that we will be studying in thermodynamics. So don't be confused. Waves, you only study the transfer of energy. Thermodynamics, you study the transfer of energy and transfer of matter. Okay, so it is the wave of motion. So you can simply define as like the mode of transfer of energy of one form or to on other form from one place to on another place is known as the wave motion, or you can simply define as the propagation of disturbance onward in any material, media, solid, liquid, gas due to the repelled periodic motion of the particle of the medium about their mean point or the equilibrium position. That is a wave motion. So now we take about which type of wave motion. So when you take a stone, throw in a pond, you can generate a wave. Simple. Okay, so which type of wave motions? So it is the two types. First is the mechanical wave motion. Second, non-mechanical wave motion. So what is the mechanical wave motion? Mechanical wave motions are those which need a medium to propagate from one place to another place. Medium requirement. Such type of waves which need a medium to propagate from one place to another place is known as the mechanical wave motion. Like sound wave, like wave on a surface of water. When you throw a stone on a pond, the wave which would generate on the surface of water is known as the non-mechanical wave. Okay, so what is the non-mechanical wave? Let's see. So non-mechanical wave is such type of wave which do not need a medium to propagate from one place to another place is known as the non-mechanical wave. Is simply known as electromagnetic wave. Like example, a light wave. Okay. So So if the disturbance produce the travel onward in the medium with the energy transfer at every section of the medium, then the wave motion is known as the traveling wave motion or propagating wave motion. So it is divided in the two forms, mechanical and non-mechanical. You understand the two types. So let's come when you the mechanical wave also divided into the two categories. First, transverse wave. Second, longitudinal wave. What is the transverse wave and longitudinal wave? So the wave which disturb the particles of the medium. So we are categorized as which type of mediums will vibrate when waves are traveling through that medium. On this basis we categorize the two types of mechanical wave, that is transverse and longitudinal wave. So what is the transverse wave? In a transverse wave, the particle of medium will propagate, will oscillate. The particle of medium will oscillate perpendicular to the direction of propagation. That is a transverse waves. It's just a perpendicular. And when such type of wave which oscillates the medium of particle perpendicular to the direction of propagation of wave are known as the transverse waves. Example, let's see example. Light waves or wave produced by the transverse vibrations of strings. Okay, so let's see about the longitudinal wave. Longitudinal wave, such type of wave which oscillates the medium of particle along the direction of propagation of wave are known as the longitudinal wave. Okay, understand the confusion? Okay, let's example about the longitudinal waves is produced in air. The wave produced in air, sound wave, or wave transmitted along a stretch string, like that. So okay, so what is the progressive wave? So this is the two different remarks. If the disturbance produced travel onward in a medium with the energy transfer at every section of the medium, then the wave motion is known as the traveling or propagating wave motion. And well, if produced disturbance in a medium do not travel onward through the medium and hence there is no energy transfer at any section of media, then it is known as stationary wave or standing wave. Understood? In a propagating wave, energy will be transferred, but in a standing wave, energy will not transfer at any section. Remember these differences. So we study the types of the waves. So we are going to see, let's see about the electromagnetic wave. They do not need a medium to transfer from one place to another place, just like light wave. So what is useful? Okay, so it is very useful. Very in every competition exams, one question will be come from here in this unit. So I will explain you in later, but simply electromagnetic spectrum. So in electromagnetic spectrum, radio wave, microwave, ultraviolet, visible, infrared, X-ray and gamma rays. Okay, so we will be understood in a later in my second video. Okay. Okay, so a remark is inertia of the medium. I have told you that you need a such type of medium which have elasticity and inertia. Why I tell you? The answer is the elasticity of a medium bring the oscillate of particles of the medium across their equilibrium position. Well, the inertia of medium carries the oscillate particles across the mean position. Remember, there is the very small difference between the equilibrium position and mean position. Generally it is the coincide, but sometimes it is the different in internally materials, internal medium. Okay, you understood? So let's about the some important definition in quote terms about the waves. Okay, so amplitude, what is the amplitude of wave? The maximum distance from its equilibrium position or a mean position by a wave is known as a amplitude. That means maximum displacement, maximum distance which travel by a wave from a mean position is known as the amplitude. Okay, a wavelength, what is the wavelength? It is the, you can define many ways. Don't remember only these words of the definition. You can define. Okay, let's see. We can define a wavelength in many ways. Let's see. A distance between two nearest particle of medium which are vibrating in a same phase, driving distance medium, or the distance traveled by a wave in a one time period, or so the difference between two successive crest, or two successive throat, two successive compression, two successive nearest successive rarefaction is known as the wavelength. Remember that the characteristics of transverse waves will be will understand by the crest and throat. Let's see here. See, the when a wave in a transverse wave, medium will vibrate at a 19 degree, okay, to the direction of propagation. So when you see upper state, the highest displacement in positive direction, that is the crest, known as the crest, and when you see in the negative direction or the belowward, that is the throw. Okay, don't forget it. So two successive crest, let's see, two successive crest, nearest to successive crest, that means the distance between two nearest successive crest is known as the wavelength. Similar, the distance between two successive throats are known as the throw. Let's see in the longitudinal wave needs a more medium. So when a medium is so there is a compression and rarefaction phenomena where there is a pressure is much high, okay, that are known as the compressions, and where there is a function there, and such type of places where there is the less pressure as compared to the previous, that are known as the rarefaction. Okay, so distance between two compression are known as the wavelength, and distance between two successive rarefaction are known as the wavelength. So you can define many ways. Okay, simple, understood? So what is the time period? Time taken to complete a one cycle or a one wave is known as the time period. Okay, so what is the frequency? The number of waves in a 1 second. That means how much time a wave repeat its position in a 1 second is known as the frequency. What is the unit of frequency? Units of frequency is per second, or it is known as the hertz, as the honor of scientist, mathematician, hertz. Okay, also you can define as frequency is equivalent to inverse of time period of wave. So let's see a wave velocity. The distance traveled by a wave in a 1 second is known as the wave velocity. Is known as a wave velocity. So we can simply know as v is equal to lambda is the distance, t is the time period, and also we have studied that 1 upon t is equal to frequency, which is represented by nu or n. So v is equal to lambda upon t is equal to n over n into lambda. So what is the wave number? The number of waves in one distance. The number of waves in one distance, and it is equivalent to the wavelength, inversely wavelength, that are known as the wave number simply. Okay, let's see a different slides. A different characteristic is the Mach number, which tell about which type of wave, sonic, supersonic, simple, which type of is the velocity. So the Mach number is defined as the ratio of velocity of body to the velocity of sound in a medium and to the velocity of sound in a air is known as the Mach number. So when a Mach number is less than 1, that means it's the simple velocity, but Mach number nearly equal to 1, that is a sonic velocity, and when a Mach number is more than 1, that is a supersonic velocity. Understood? Let's see different point. Which is a more sensitive, eye or ear? Are you know about it? Let's see. Range of eye. As we know that range of eye in a visible range of light is from, what is the range of visible light? 4000 angstrom to 8000 angstrom, but accurately is 3800 angstrom to 7800 angstrom. Okay, so we know as the V is equal to n lambda. We have studied previous slide. So n is equal to c over lambda. Here c is the velocity of light. So see, what is the value of velocity of light? 3 into 10 to the power 8 meter per second. Okay, but it is the variable in such different type of medium and also the special type of relativity. So don't go here there. We are here on topics. So what is the range of ear? A human can audible only the 20 hertz to 20,000 hertz. Okay, B is equal to n lambda. Okay, and what is the velocity of the sound? Is 332 meter per second. So when we change it by the formula C is equal to n lambda, that the answer is 66.6 millimeter to 66 meter. That is our range of audible. Anybody person should talk from our distance 60.6 millimeter to 16.6 millimeter, so we can audible what they are talking. That means air is more sensitive at a frequency 1000 angstrom. If any light of frequency light which component is the frequency is 1000, we can our ears are very sensitive. We can very simply understand what they are talking about at this frequency, and the eye is more sensitive at the 5500 angstrom. Which color have a wavelength of 5500 angstrom? That is yellow. Remember that. These questions comes mostly in the competitive exams also understood. So okay, so what is a phase? Phase talk about the distance and time of wave. Okay, otherwise it's nothing a meaning in physics, but the meaningful, very important is the phase difference. Okay, phase only talk about the position and time of wave, but it's not much important. Important is phase difference. What is the phase difference? Phase difference tell us how much or when one wave go outward, which of angles, how much fast to others is known as a phase difference. Means for a comparison between the waves, use the phase difference. Okay, so phase difference and path difference have a small relationship, and you must be read and remember it. That is the 2 pi upon lambda into path difference is equal to 2 pi upon lambda into phase difference. Okay, so let's see difference. What is the angular frequency? Omega is equal to 2 pi upon t. I told you phase difference, it talk about phase, space and time of wave. So if we change the time rate of change of phase, the ratio of phase difference with respect to time is known as the angular frequency. That means omega upon 2 pi upon t. What is the 2 pi? 2 pi is the whole distance travel in a one cycle, and t is the time period. So omega is the, what is the omega? The ratio of phase difference with respect to time is known as the angular frequency. And the second thing is time, and but is space. So the space rate of change of phase, that means the ratio of phase difference with respect to space distance, are known as the propagation constant, that is represented by k, that is 2 pi upon lambda. So omega over k you can simply see here. Okay, omega over k is equal to lambda by t is equal to, and lambda is equal to b. That is simply you can understood it. Okay, so you can generally write a equation of wave. So let's see, a wave is going in a positive direction. We can simply any function which is dependent on others, we can simply explain by the x is psi is equal to f of xt. Okay, so when we see our two functions which are nearly same, so we need to use, so we must satisfy the condition of simultaneously. That means no change in shape. So we taken a wave function psi with respect to t and with respect to v. We wanted to equally, because they satisfy the condition of simultaneously. So we get a psi in a positive x direction, that is f of vt minus x, and function in a negative direction is vt plus x, after satisfying the condition of simultaneously. So now the general equation solution will be psi is equal to f of x minus vt plus g of x plus vt. So we know as the wave equation is a second order differential equation. So we are going to differentiate it, then we get the del square psi over dx square is equal to 1 upon v square into dx square upon dt square. This is the general equation of wave in a one direction. When you use in the three direction, then you written as the del square psi is equal to 1 upon v square into del square psi over del t square. Okay, let's see different velocity of sound wave. We have studied about the longitudinal wave. So there is a very beautiful fighting between the two scientists, between the two geniuses of the physics. One is a Newton, second is a Laplace. Okay, so we are going to say the velocity of longitudinal wave like a sound in a medium, in a air. So the velocity, as we know that the velocity of longitudinal wave is equal to root k over rho. That means is the under root square of the square under root of bulk modulus of fluid to the density of fluid. Okay, liquid and gas are known as the fluid. Okay, so Newton formula for velocity of longitudinal wave or a sound wave. Newton assumed that the propagation of sound wave in a medium was a isothermal process. Newton assumed it is the isothermal. When a wave travel in air, it is an isothermal process. So he used the isothermal process equation, that is P is equal to constant, and he got it the bulk modulus of the medium is equivalent to the pressure of the medium. So that is V is equal to root P over rho. So P, as we know that the pressure measured in the mercury, atmospheric mercury, 76 atmosphere of mercury. So he calculated and get the value of 280 meter per second. But experimentally we know about, they know that the sound of this velocity of sound is the 332 meter per second in air. So Laplace come and he suggests that when a wave, longitudinal wave or a sound wave travel in air, here is an adiabatic process. It's not a thermal like a Newton, it's the adiabatic process. So you write the adiabatic equation, that is PV power of PV P into V power gamma is equal to constant. Gamma is the ratio of Cv and Cv. So what is the Cp? Specific heat at constant pressure, and Cv is specific heat at constant value. Okay, the value of in air or a gas, the gamma is 1.4. It is the unitless. Okay, so you can derive it and put the value, and he get that the bulk modulus is not only equal to the pressure, but also the multiplication of gamma and pressure is equal to the bulk modulus. Okay, so he put the equation V is equal to square root gamma P upon rho, and it's experimentally matched. His value result is experimentally matched 332 meter per second. Okay, so what's the effect between by the medium on a wave? So when you increase the effect of pressure, there is no changes, there is no effect on the wave when you increase or decrease the pressure of the medium. If we increase the medium, density will become, if the pressure will become pressure low, then density will be high. Okay, that's why pressure not effect on the medium. So let's see the temperature, effect of temperature is its effect. The velocity of sound in a air is directly proportional to the square root of the temperature, absolute temperature. Okay, and the density is inversely proportional to the square root of density. Velocity inversely proportional to the square root of density. Okay, standing wave, reflection, and all the things we can study. Okay, just remember that nodes and antinodes. What is the nodes and antinodes? Nodes, the amplitude is 0, and antinodes, the amplitude is the maximum. Simple. So one thing, that where is the fixed or a closed, there is a boundary condition is x equal to 0, gamma psi is equal to 0, that will be the d psi by dx equal to maximum. Like these things we will study after. Okay, Doppler shift effect, there is only two formulas we can simply understood. Okay, so I left you that about the electromagnetic wave. So electromagnetic wave, this is a spectrum of electromagnetic. So radio wave, microwave, IR, visual, ultraviolet, X-ray, and gamma. So radioactive wave, in a radioactive wave, wavelength is very high. That means energy is very weak. That means frequency is very weak. And a gamma ray, which is the different side, there is the frequency wavelength is very low. That means energy is very high. That means frequency is very high. Okay, so those who have more energy, who can very powerful penetrate any obstacles. Okay, so the gamma rays are high penetrating power as compared to radio wave. Radio wave have a less penetrating power. Okay, so you must remember this spectrum. Why? Because when you study about the optics, you must know about the IR to IR visual spectrum, visual spectrum, about the light waves from the 4000 angstrom to 8000 angstrom will be studied in the optics. When you study the spectroscopy, we must know about the IR and X-ray. When you about the gamma ray, study about the gamma rays, you must be going to study the nuclear physics. And radio waves and microwave, it is the electronics and communication branch. Okay, I hope I am not taking much time of you. So optics is the three types, simple last slides: geometrical optics, physical optics, and scattering. So we will be after that study. Okay, thank you so much. I hope you give me the second chance to prove myself, and we will study very well.